Polynomials, right? GCF, that's your greatest common factor, perfect square trinomials, and a difference of squares. Right, first thing, greatest common factor. Right, so if your polynomial has coefficient variables that are all the same factor or share a factor, you can factor that out, right? And make that the coefficient times your entire polynomial. You can think of it at like undistributing. All right, so in our example, I've got 3, 18, and 27 as the coefficients. They're all multiples of 3. So 3 is its greatest common factor. We divide each variable by 3, right? And then we take that 3 and put it on the outside, right? So 3x squared plus 18x plus 27 becomes 3 times x plus 3 times x plus 3. Right, kind of simple. So once you've taken out the greatest common factor, then you move on, continue to factor. All right, so here's an example. Good time to pause the video. All right, we'll go through the steps, right? So find the GCF for the polynomial. In this one, you should be able to tell very easily that it's 2, right? So divide each part by 2, and we get 2 times x squared plus x minus 12. And then we just need to factor our x squared plus x minus 12. Right? Since b is positive and c is negative, our larger factor for 12 will be the positive one. We get x plus 4 and x minus 3. Right? So 2x squared plus 2x minus 24 factors to 2 times x plus 4, x minus 3. Next example, another good time to pause the video. Right, hopefully you could tell real quick that everything is a factor of 5 or a multiple of 5. So divide it all by 5. And now we have 5 times x squared plus 7x plus 10. Right? Since b and c are both positive, we're going to be having an addition sign in both binomials that it factors to. Factors of 10 are pretty simple. We get 5 times x plus 2 and x plus 5. Right? Moving on, perfect square trinomials. Right? So these are the results of either a plus b squared or a minus b squared. Right? It's not anything different from what you've already been doing. It's just that if you see it either as a trinomial or as the binomial squared, recognizing this pattern is going to make it faster and easier to either factor or multiply. So it's just something to get used to. And sometimes the questions get asked a little bit weird, right? So examples, x squared minus 18x plus 81, right? We know that b is negative and c is positive. So that means we're going to be minus in both examples. And I've got positive and positive, which means that it's going to be positive in both examples. X minus 9 squared, x plus 5 squared. All right. Completing a square. So given 2 terms from a perfect square trinomial, find the missing term. Right? So in order to find c, what you do is you take b, the middle number, divide it by 2, and then square it. There should be an x right here. I'm going to have to edit this. And then to find b, if you don't have it, you have to take the square root of c, multiply it by 2. So in this example, you get x squared plus 12x plus what? Right. Well, c is equal to b divided by 2 squared. Right. B is 12 in this example. So we get 12 divided by 2, 6 squared. C is 36. So our answer is going to be x squared plus 12x plus 36. Pretty simple. Here's some examples for you where you have to figure out the middle term and the last term. So if we know what c is the result of multiplying a number by itself, which is squared. So we find the square root of c, multiply it by 2, right? The square root of 121 is either plus or minus 11, right? When you're completing the square, you're going to have to take your cue from the given equation if your b term is positive or negative. In this case, it tells us in the equation that it's going to be negative, so we get plus or minus 22 as a choice. The equation tells us we should pick the negative one, so we get x squared minus 22x plus 121. And this example should be 16x. Right? We've got b So we need to find what c is. C is going to be equal to b divided by 2 squared. Right? 16 divided by 2 squared, 8 squared is 64. And so your answer should be x squared plus 16x plus 64. All right, factoring a difference of squares. Right? Once again, real simple, and you can figure it out. It's just if you pay attention to the patterns, it's going to make your multiplying and factoring faster and easier. All right, so if you have a squared minus b squared, it's called a difference of squares because both numbers are squares. Right? And that should be a B. This is not going good for typos, right? Result of number squared. So it factors out to a plus b times a minus b. Here's some examples. X squared minus 81 equals x plus 9 times x minus 9. That's why your b term in the middle cancels out. And x squared minus 169, x plus 13, x minus 13. All right, so here's some examples. Let's see if you can do this. I didn't give you an example yet with a coefficient in front of x, but you should be able to figure that out. What's the square root of 25? 5. Square root of 4? 2. Right? So you find, right, here it is, 5 squared and 2 squared. You get 25 squared minus 4, that should be an x, equals 5x plus 2 and 5x minus 2. And then this next question, what would be the resulting difference of squares polynomial if one factor is 3x minus 4? Okay, if it's a difference of squares polynomial and one factor is 3x minus 4, the other factor has to be 3x plus 4. And since it asks for the resulting difference of squares polynomial, we're going to multiply 3x minus 4 by 3x plus 4, and we get 9x squared minus 16. That's the end. I'm going to have to go back through and put in all the edits for where I forgot to put x's. But don't forget to like and subscribe. It's factoring special polynomials.